have Visual Studio installed? If you do, that'd be great, because this is all set up for Visual Studio. In the Discord channel, under announcements, there is a download. I have Discord installed on there? Probably should have logged in before I plugged in, huh? Let's just walk through it.
These the same downloads from last week?
Yeah, same project. I'm just gonna, like you said, I'm just gonna move stuff around instead of trying to explain it.
Gotcha.
So under programming, under the programming page, under announcements, if you slightly scroll up, there's a preset SFML zip file. If you download and extract it, you will get this folder here with preset SFML in it. And if you have Visual Studio installed, just double click on Project 1 SLN. This will fire up Visual Studio and it'll have everything preset. SFML will just work out of the box. You don't have to spend a day trying to set it up. See if it'll run. Okay, there it is. And if I debug it, here it is. It's got the clouds, it's got the B, but literally nothing else happens. The escape key does exit the game, right? So if I run it again, let's say we want to start building this game. Like, I don't care for this B, I want something else, right? I want a sweet Butterfree from Pokemon, I guess. Right? So I'm going to go Butterfree Sprite. Images. I'm going to go to the first one. This guy here. I'm going to save as. And I'm going to save him into that folder that I just extracted. Preset SFML, SFML, graphics. All your graphics are in here. Save.
This image looks like it'll work, but if you want to pick something else, you might want to pick something that's a PNG with a transparent background.
That's the thing. I'm going to go over that right now, actually.
Okay.
This is a WebP, and this I don't think SFML works with WebP. It does work with JPEG and other ones. I legit had to download GIMP just to get it to work. If you have the newer Windows and you have Paint 3D, that works. But I don't have Paint 3D. This is Windows 10. So I'm going to go File, Export. Where is it? Export as, and I'm going to go ahead and convert it to. Actually, hold on. Before I convert it, this Butterfree is actually kind of big. I want to resize it. Image, scale image. And go percent. It's linked. I'm going to shrink it to 20% of its size. Scale, file, export as, and I'm going to go ahead and export it as a PNG. But I think there's you could look up the list of things that work. Where is it? Here it is. PNG. Found it. Export. Export. Okay, here it is. I'm going to go ahead and rename it to BD. So in here, I don't know if you guys remember, setting up a texture and then link it into a sprite. It's already in the thing here. We're just going to find B. Here's the B. I don't want it to be BB. That's all I'm doing here. I got the picture and I change it to point to BB. There's my Butterfree, but it's looking the wrong way, you guys. It's drifting backwards. It's moonwalking. How do I fix that? Right? Like, what's going on? This is actually a pretty easy code to fix. Discard. Got my cheat sheet here. It's something called scale. All that. So here's the B. It's set up. All this garbage. I'm gonna just throw it in here with the setup. I'm gonna go. That's small, and then we're calling it. What is it called? Sprite B. Sprite B. Dot scale, and I'm just inversing the scale. So if I run this now, okay, it's facing the right way. Turns my B around, or my Butterfree. And you can do that mid-code. You can have it swap back and forth if something happens, right? So the code just swaps it back and forth. It's also kind of straight. My Butterfree's like, I want it to tilt. I want tilt on it like it's got speed, you know what I'm saying? You guys know what I'm saying? So just set rotation. Here it is, control copy. And toss it in here as well. Where is it? So right after this, Set rotation 60. I think that's wrong actually. Let's see. It's like on its side now. I want negative 60, I guess. That's pretty good? No, I want it, it's leaning too hard. The thing is, like, depending on speed, I can set rotation, right? If it's certain speed, I can increase the thing, because negative 60 is a hard lean. Let's lean her back a little bit more. Negative 40. Oh, it's off screen. Let me load that again so we can see it. There it is. That's a pretty good lean, I would say. It's leaning not bad. But currently, we're not doing anything. I can't control my Butterfree, right? How do I make it move? Up, down, left, right, what's going on? Right now, it just moves left to right, yeah? So we know that code's there. And we also have this code here. It's keyboard, it's key press, keyboard escape, windows.close. If you press the escape key, it closes the window, right? We're just gonna go ahead and copy this and paste it right under. I'm going to say, if I press up, what will happen? It'll close the window, yeah? But I want to make the bee or Butterfree move up and down. So I'm going to go down here and steal this code. This code here is what makes the bee move left and right? We see it drift. I'm going to dump this in here. Straighten this out so we can look at it real quick. There's all kinds of dumb garbage happening in here I don't care about. I mainly want to cut this out and just keep it like this. So what does this part do here? It says sprite B set position. Let me draw it real quick. We have our screen. And we have to remember this is 0, this is 1920, this is 0, this is 1080. Right? The code sprite b.getPosition.x. So if my b is here, and I say get x, it's going to return the x value, right, of my b. So x is left and right. So wherever the b is, let's say it's right here on the screen, it's between, so it's like at 1330 or something here, right? That's where my b is. What's up?
What library was this again?
This is SFML.
Yeah.
If you have Visual Studio installed, that package from Discord just does everything.
I'm getting no errors.
If Professor Gideon, can you? I'm gonna think you bulldozing.
What's the version you're using then?
SFML should be like 2.5. But again, it's built into the folder. You shouldn't have to download anything.
Yeah, I did. You're right.
And this other number is our height, which is up to 1080. We'll say 810. So when you see this code here, sprite B get position X and sprite B get position Y, all I'm saying is give me X, the 1330, and give me Y, the 810. That's where the B is. But I want to say when I press up, give me these numbers, and then go ahead and add 1. I want to go up, right? So to go up, I would have to minus, right? Because again, I want to go up. So -1 will move my B up 1 pixel, right guys? So all I have to do is go, hey, set my B position to its current position, but go ahead and -1 from the Y. -1. So if I press up, give me my B, wherever it is, add 1 pixel to it, or -1 pixel from it, right? That's all I'm doing, so let's run it. Where's my B? It's down there. There it goes. I'm holding up. But if I hit down, nothing happens. But it goes up. Well, that's simple enough, right, guys? What if I copy this again? I'm going to copy this guy. Control, copy. Paste it again. This time I'm going to say when I press down, and instead of minus to the Y position, the up down, I'm going to add 1. It seems kind of weird. By adding 1, we're going down because top of the screen is 0, bottom of the screen is 1080. So when I press down, add 1 to my y-axis. Let's see what happens. I'm going to press up, I'm going to press down. Up, down, up, down. It's on the other side. There it is. So I can make my butterfly move up and down now. What if I want to make it hit this tree? How do I make it hit the tree and stop, maybe? Let's look at it like this, right? We know where the tree is on the screen. There's like multiple ways to do this, but we're going to do like this way is okay. What do you think the position of the tree is on the screen if I run it again right now? Run. Move my butterfly up. So at some point, remember I went over the numbers of the screen? It's 00 to 1920. So from left to right around here, we'll say 1200. What do you think? The tree starts at 1200. So when my bee's going this way, it starts at 1920 and it goes less, 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 less. And around here it's 1200, right? So I'll say, I'm going to copy this again. Yeah, I'll just copy this again. I'm going to copy this code here. And I'm going to move it over to update scene. Just going to go to the bottom of update scene here. And paste this. And I'm going to steal this again, right? We want the left, right. Left, right is X, yeah guys? So I'm going to steal this sprite b.getPosition X thing, which returns where in the screen on the X is my butterfly, Butterfree. I keep saying B, guys. Maybe that wasn't the way to go. I'm going to go ahead and delete all this garbage in this if statement. These are all ifs, boys. So I go if sprite b position.get X is what, right? If my tree is here, I'm going that way. So if it tries to go past this, it would be less than, greater than,
Less than or equal to?
less than 1200, we'll say. I'm assuming that's where my tree is, right? Less than 1200. We're going to say if it's less than 1200, take my B and like push it back 2 pixels on the X. So I'm saying when it hits this part of the screen, the 1200, make it go back, push it back. Let's see if that works. Okay, I'm not quite hitting the tree. Let's lower it down. Let's make this 1100. Yep. So what, like 1150? Let's do 1150. Is that looking pretty good? It's hitting the tree and getting pushed back. It can't get through. Well, that's no fun. How do I make my butterfly? Let's say I want to get under the tree. Let's say if I get under here, I want the butterfly to go under. How would I do that? Right? Because currently I'm saying, hey, if I hit this line, push me back. Let me wipe this off so I can give you a better idea. If you think of it again, it's saying, let's see here. We said 1150, right? Here's my screen. Here's the line for 1150. So if my butterfly is anywhere in this area, it's going to get pushed back 2 pixels. But I want to say, hey, right here, this part here, this chunk here down here, this is fine. So how do I define this to be open? Right? Like I said, if we look at the code, 1150, and I'll go and instead of X, I'm going to say Y, right? X means left, right on the screen. Y means up, down on the screen. So if my Y, what is the number here? What is this below here? How low do you think my tree goes? We know this is 1080 down here. So let's say 850. So if my butterfly is higher than 850, or no, if it's higher than 850, push back. But if it's lower than 850, okay, so if it's lower than 850, push it back. If it's higher than 850, don't push it back. It's a and. So both things need to be true. My butterfly needs to be beyond 1150, but and above 850 for the pushback to happen. They have to be both. That's what the and is doing. So I go, and it's less than 850. Let's run this. So I'm gonna hit. Now at some point, the butterfly, as it's moving down, each time y is returning. What do you think the height of my butterfly currently is? We'll say it's at, what is it, 600, 700, 800, 850, oh my God, it's going. Well, if we look, there's another problem. Once it's here, it's going, but if I come back up, it starts getting pushed back. You see that? Why is that happening? Because if we look at this again, I'm saying if my butterfly is in this zone, push it back. So just hold zone. This is my 1150. How do I get the tree? So I want to say if my butterfly hits anywhere in this zone, I want this zone freed up. If my butterfly is inside this square here, I want no pushback to happen. I want the pushback to only happen in this chunk here. Right? So currently, the whole thing is pushing back. I want to get rid of this chunk in here. How do I get rid of this chunk? I have to go, okay, well, if it's less than, did I put less than or higher? Let's see. This is less than 1150, right? How thick is the tree, you guys think? 900? Right? We'll say the tree is 100. So if the butterfly is greater than 900, don't do the pushback. Right? I'm going to just jam it in there. See if that works. So I'm going to go ahead and copy this whole chunk again. Control copy. Space paste. And then I'm going to say greater than, the tree's about a couple of 900. So I'm saying if my butterfly touches anywhere in here, go push back 2. But if it's here, it doesn't matter because it's no longer greater than 900. Past here, it's less than 900. Right? So if my butterfly is here, this is what? The coordinates here are like 600 and this is left and right, 600, 800. That's outside these values. It's no longer in between those two. So it won't trigger, it won't push back. Let's run that. Up, we're moving. We hit the tree, we're hitting that 1150. I'm gonna go down until we're under it, and it's gonna squeak by, and if I fly back up, it's not getting pushed back. Remember that 900 I did? At some point, that 900 still exists. It's actually pretty skinny. See that? We're flying out. All right. Does anybody want to suggest the feature we could try and do right now? Like, what's something you would think?
I do. I want the butterfly to spin as it's flying.
You want it to spin as it's flying.
Oh, the powder.
So that would be rotation, right? The rotation thing we did earlier.
Sun sport.
Set rotation -40. So there's 2 ways we could do this, I guess. There might be a feature to get rotation. I wonder if that's a thing. Let's see. The way to test if something's a feature is you just type it. Sprite B dot, and it should be get. And then we do have a get rotation. Holy smoke, it's right there. It's showing up that there is a way to get the rotation. So if I say sprite b dot get rotation, it'll return that negative 40, right? So how do I get, knowing that, and then set rotation sets the rotation. Let's go back into our update the scene thing here. I'll go to the bot. Where's the end of update scene? This is update scene. This is where we added the pushback. So I'm gonna say sprite. Ooh, I'm spacing you guys. Where's B?
SFML.
Okay. Sprite B dot set rotation. And I'm gonna do sprite B dot get rotation. I'm gonna close that. I have to do the, okay. So what this currently does is just set it back to negative 40, right? I set it to negative 40 up top. And when I go, hey, set rotation to whatever rotation is currently, it'll make it negative 40. Okay, so if I wanted to keep spinning forward, I have to up the negative value, right? So it's at negative 40. I wonder if it loops properly. What happens after it hits like a...
It should just handle.
You think you'll loop it?
360 rotation.
So we'll plus 1. So 60 was a stronger rotation. Negative 60. So we'll go, okay, well, we'll plus 1 actually reverse it back, doing minus 1. So minus 1, oh. So get rotation returns negative 40. And minusing 1 from negative 40 is adding 1. It'll become negative 41, right? Or am I tripping? And this will happen every frame. So even 1 might be a lot. It might spin quick. Let's see. Literally, that's it. We're trying to make the beast butterfly spin. Spin butterfree. Oh my god.
There you go.
It's interesting that it's moving up and down because it's rotating it on the square. So the butterfly is loaded in the square, and this is being rotated around. So technically, they're both being loaded to 0, 0, but when you change the rotation, it actually moves where it is. It's not being rotated in place. If that gives you an idea. The 0, 0 should still work, because I don't know. Let's
Is
see.
it possible that you can make the wings move?
Yes, I would need multiple butterflies. It's popping off. Well, technically, we can make it go the other way, right? This minus 1 makes it spin forward. So if the idea is correct, plus 1 should make it spin the other way. All right, let's do another one. I'm gonna cancel this out real quick. All right, like you said, not flap its wings, but let's say when our butterfly hits the tree, we want to make it look the other way. We'll reverse where it's looking if it hits the tree. So in this code here, if this code triggers and pushes back, I could just go, hey, remember when we did the scale thing here? This is what made it look the other way. So if I just dump this in here, won't it turn the butterfly around when it hits the tree? It's still rotating, let's see. And it's flapping like you wanted. Right? Because I'm inversing the scale. Did I not clear out that code? Oh, I did the wrong. I did like a turn. I thought that was a comment. Let's try it like that. Let's see what happens now. When it hits, it should reverse. It doesn't like it, guys. But if I go back down, it'll get under. Woo! It's free. Anything else you guys want to add? Like, what's something you would attempt to change in this code if you were interested? What's something you could try and do?
Can
Add flowers.
can the clouds block the butterfly?
Yeah. Trying to remember. The thing is, what we're currently doing is when the butterfly hits a part of the screen, it's not actually hitting the tree, it's just hitting this point on the screen. There is a way to go, give me the coordinates of this tree. So to make the butterfly react to the cloud, I would need code that gives me where the cloud is. So when I go, hey, is my butterfly crossing over with this cloud? Now, I'm trying to remember, because chapter 6 covered this. We never got to chapter 6. I'm trying to remember how to get, there's a way to get global bounds, but I don't know how to put them into X, Y. So that's beyond my scope currently. We're able to use whatever code we have currently. And the code we currently have is what? How about this? When the butterfly hits the tree, let's kill it. We could make it turn into a tombstone. Right? We have that code from a couple of chapters ago. Let's see here. If I open the newer chapter real quick. Here we go. Where is it? Notes. Chapter 5. Code. No, don't. Whatever. Here in Timber, there's actually a tombstone that they load in. Graphic tree, bee, cloud. Where's that tombstone at? Am I losing it? Long, chop, depth, out of time. No, it's not it. Branch. River? It should be like rest in peace or something. Cloud. Here it is, rep. I'm gonna copy this. Prepare the gravestone. Control copy. I'm gonna close this. Let's see. Just dump it in here at the top, right? I'm gonna dump, prepare gravestone. So it's a texture called texture rip. It's like a little tombstone, sprites, and then set texture, texture rip, and set position 600, 860. Let's load this. We should see, where is it? Oh, we didn't draw it. So I made the sprite and I set its position, but I never said, hey, show up on the screen, right? Which is at the bottom. At the bottom here, draw a cloud, draw a tree, draw a bee, window, dot draw, and then what do we call it? Rip or something? What was the name? It was.
Where do you find the Timber file?
It's already inside the preset, or at least the 3 of them. If I go to Discord right now, hold on. In Discord, there is beginning C programming. This is the PDF of the book, but all of the chapters are in this zip here, the SFML notes. This has all of the completed projects from the book. So if you look in here,
It only shows me that's BB on my file.
in announcements,
No, like when I did the.
yeah, no, so preset SFML is what you downloaded, this guy. This guy is only the chapter 3. This guy here, notes main, is all of the chapters.
Okay.
But like, you have to set up Visual Studio to work with SFML with those chapters. The preset one is set up to work out of the box. So if you pull these guys, you'll have to copy them into preset, otherwise it won't run. Now, where was I on the tombstone? Oh, it's called texture, sprite rip. That's what it is. Sprite rip. Okay. Now it should draw in. Okay, there's my tombstone. Okay. I want to go ahead and hide the tombstone off screen. But you guys saw it just now, right? Where the tombstone was? There it is. And where is it set? Tombstone's right here, and I said 600, 800. So that's where you guys saw it. On the screen, this is 600, 800, apparently. Right? I'm gonna go ahead and just toss it, I don't know, below the screen. Make it right here. So I can't see it. All I have to do is just move it down a little bit. So that would be on the Y, which is the second number, right? And we know the bottom of our screen is 1080, so I'll just make it 1200. So if I run this, we can't see it, it's just below the screen. And when my butterfly touches the thing, I'm saying push back, right? Where is it? push back my butterfly. But instead, I'm gonna say, put my butterfly at, I don't know, 3,000. And I don't care, 0. Right? So where does that put my butterfly? It puts it over here somewhere, off the screen. Right? And instead, I'm gonna go spirit. Actually, no, I need to do it backwards. Sprite dot set position. Close it. Get position X. Copy. Apostrophe. Position Y, and I need to do this before, not Control X and throw it on the top. So what do you think this is doing here currently? I'm saying when my butterfly hits this line on the screen, this line here, I can sneak under, but when I hit this line, go ahead and toss my butterfly off the screen out here somewhere, and just go ahead and put the tombstone wherever the butterfly was. Actually, put tombstone, then toss the butterfly, in that order. So if I run this right now, and I hit the tree, right? Now the butterfly, no, I gotta get under. He's dead. Okay, hold on. The next one, I'll get it. Okay, no, it's spawning me too high, I can't get under. This time, I'm gonna hold down right away. Hold on. This time I'll make it. Okay, I'm holding down. It's gonna make it. There it is. I'm gonna make it. I did it.
You beat the level.
I did it. I won the game that we just made, you guys, together. I think that's good. Once it's off, it's gonna come back around, and I'm gonna hit the tree again. Pow. That easy. Alright, I hope that was fun. I hope you guys learned something. Yes, sir.
I figured out how to do the sprite collision.
Sprite collision.
So-
Oh, okay. The
See if
get.
it's collide.
What is it? Is it
It's actually pretty easy.
get global?
Yeah, sprite1 dot get global bounds dot intersects. It's one long line, but it's all just a function of all.
Okay. So if we hit the tree, we'll do
So,
this.
For example, it's a sprite b and sprite tree.
If.
Right.
Did you want to type it out?
Sure.
Right here. Go for it. So this is right under the collision code for the tree.
Right. So if we say something along the lines of
Yeah. That pawn game goes over to chapter 6.
yeah. So if it's I got not on the home keys.
Mhm.
Sprite still not
Little
on the
bit,
keys.
little bit up.
Okay, hold on. There
You'll
we
get
go.
it. You'll get it.
Sprite
It's not a manual.
dot get global bounds. There it is.
Okay. Oh my God. So it's that easy.
Yeah, and then that's it. And then dot intersects,
Nice.
and then open parenthesis, and then in here you get the global bounds. of the other
Do
things.
the
So,
sprite cloud
sprite
cloud 1, 2, or 3.
one dot get global bounds, and I misspelled cloud, but
Just
other-
missing a C. We'll fix it.
Yeah, but other than that, that should be.
And what do we want? You can just do the pushback.
Cloud one, so, let's say, sprite b dot,
Set position.
sure.
If you want to do the pushback.
Here,
Or-
how about this, set rotation, sprite b dot get rotation minus, 2. So if it hits the cloud, it'll start spinning
Okay.
back.
Let's go ahead and get rid of the other 2 clouds real quick so we know which one's one, which one's which. So this is set up for cloud 1. I'm gonna go ahead and get rid of cloud 2 and cloud 3 so we know which cloud we're looking for.
So you got rid of cloud 2 and cloud
Okay,
Well,
so-
you're gonna hit the tree and die.
Hold on, the bee will come back. Come on, butterfly, come on. Where is it? It's off the screen. I don't know where it is. Because like if it's when I'm pressing up and down, it might end up out here or it might end up out here, and then at that point I have no clue where it is. No, okay, hold on, I can sneak under. We can sneak under and make it up. Hold on, we'll get it on the next one. Unless I hit the tree. It's okay, no, I'm gonna get it. It should reappear. Hot dog, dude.
Can you get rid of the dying?
The dying, the
code just real
pushback?
quick?
Yeah. I'll just dump this whole thing out. Okay, so now we should be able to get past the tree. Sick. And now when we hit the cloud, oh my god, dude, we're drifting.
Touches the cloud, it starts to spin. Whee!
It's gone forever.
But I mean, you could have it do anything. It's just
Yeah, did you see
checking
the collision, guys? That's insane. It's like one line.
And
I hope you guys had fun. I'm gonna keep going with the project. Maybe we'll get a Discord thing going. The whole PDF is there for you to read if you're into reading. I don't know.
Yeah, so the preset, the SFML notes, and then the PDF are all gonna be in a separate Discord channel, so that everyone, even if you're coming in new, you can catch up and just mess around and try to make the game, fun for you. But with the GitHub repository, Alex is gonna take it on next.
Yeah. If anybody has an idea for a very basic game, you could just throw it up there and then we could slap it together. How hard could it be?
Can we do
Like-
like a Monopoly game?
Oh, that sounds not very basic. We could do like a hit the tree and explode.
Or like a game that calculates the amount of crypto you have. I like that.
Sure. Like after we finish the book, we could easily do that. All we have to do is get through the book, and then let me know. We'll do it, dude. You tell me you finish the book, I will sit down and do it. We'll do this Monopoly / crypto game using real cryptocurrency that will generate using the game.
And everyone's wallets have to be.
Yeah, but like, there's much like. We're already got collision, right? Like slightly further in, I want to say, as we ignore the zombie game, there's legit a platforming game where you could jump on top of the other guy or whatever, or that other game, I forget. If you just get past the zombie game, you can create a Mario clone or a Zelda clone, That's where you kind of want to start. Like, I want to make a knockoff Zelda, just like the original NES one. Guess what? This thing can easily do it. Most of the code here is almost enough for the Zelda game. All you have to do is I load it. You guys saw the loading in the one butterfly, right? Think of the original Zelda, right? For Nintendo. It's Link, and he's got this little sword, and it's pointing up. But then you can also make him point the other way, and his sword is this way, and then point the other way. Guess what? They're all the same picture. It's just that the rotation garbage. Where it's like rotation 0, rotation 90, rotation -60. That's it. It's one picture on the NES. Oh my god, you could almost build the Zelda, dude. I gave you rotation. You have 4 Zeldas now. You could make him look in 4 directions. You need one picture, and you're like, hey, when I press down, rotate to 90. When I press left, rotate to this. When I press right, rotate to this. That's it. What was it? I think I can do it right now, right, guys? Let's see here. Remember that code we did for making the butterfly move up and down? I'm going to say Spirit B set rotation at what, 90? I'm going to copy this one. I'm going to copy this out. Control copy. Control up key. Control copy. Paste this in. And we're going to go, 180, I think. I'm going to copy this 2 more times. So this is up, down, left. I have to make it capital, I keep forgetting. Left, right, I don't know, make it what? 90, 180, I don't know, -60. And what's the other one? I don't even know. Negative 120. So if I press up, it'll be 90, down will be 180, left will be -60, right will be 120. So if I run this now, Am I saying butterfly? Up, down, left, right. Up, down, left, right. See how it's moving? The thing is, it's pivoting. So it's kind of different, I guess. In Zilda, it would rotate in place. There's probably a command for that. Currently, I'm rotating it on its axis. So its axis is right here. So when I go, hey, make this, what's the circle here? This is 90, right? So, and I go make it negative 60, it's rotating it to here. The axis stays the same. It's not spinning it in place, it's spinning it around this circle. So if again, left, right, up, down, I just move it around like this. And this is sort of what Zilda did in the original NES. There's probably a command for rotate in place instead of rotate it on axis. Either way, I think that's been great. I hope you guys found something fun and maybe interesting in this. And if you're willing or interested in learning more, pull up the PDF. If you have any questions, let me know. I'm going to try and keep bulldozing through the book by the end of the semester. Big hopes. Big hopes. We'll let Alex take over while I disappear. Yeah. Go for it.
You said we're gonna host a server on Roblox.
Anything we're gonna take it out.
Yeah.
Those kids are gonna grow. Playing new games. Staying lots longer. Yeah, I can't figure this out.
What do you, okay, did you download the preset?
Yeah, I'm ready to say.
Everybody, my name's Alex as well. Today we're gonna go over Git and GitHub. And so in the Discord, in the workshops and events channel, I posted some slides, which I'll be going over while we do this. So, okay. The reason why we want to deal with GitHub and Git is because it's very important for projects, especially at hackathons and in professional work. Basically what it is just version control. So you can work on a project at one time and other people can work at the project at the same time. And at the end of the day, you can all have one single product. So, I'll just skip through this. Okay, so first thing we need is Git. So if you just look up like Git on your search engine or whatever, you should go download Git for whatever OS you have, Windows, Mac, and then at the same time you should create a GitHub account, which is just another site, and you could use your email and whatever.
Where's the one in this school?
The workshops and events channel. Right here.
Okay, I got it.
Yeah. Okay, so if you go to the Git site, it should look like this. And then we can go to downloads. And then you can download whatever fits your computer. And it'll probably ask you a lot of setup questions, but you can kind of skip them and just keep saying okay, okay, and okay. And then when you create your GitHub account, once you finish creating your account, it should look something like this. And then from there, we could get started whenever y'all are ready.
So on Git, we download it.
Yeah, you download Git and create an account on GitHub.
sign up?
For GitHub?
Yeah.
Yeah.
I think from the last workshop, Edward had mentioned to not use your Los Rios
Yeah,
email.
that's true.
You're gonna wanna use like a.
Personal Gmail.
Yeah, personal Gmail or whatever burner account you have.
I'm struggling to create a username.
Yeah.
Hey, real quick, or
What's it? Yeah, I heard you muted, what did you say?
It's right outside, dude, you can hear him. Yeah, you can hear him.
Are you coming over to the?
Oh, I call my friend
living
living room.
Over here, where you at? You in the back.
Who was that, Keith?
Yes.
Okay, so once we're done downloading, what do we do?
So you created a GitHub account?
Yeah,
and
I
downloaded-
already did that. So, okay.
Is everyone else good?
think so,
Is everybody else following along well? Okay. Alright, so what we want to do is practice using this, because if you look at GitHub, honestly, I don't even understand what a lot of this even means. But we can use this to create our own projects and work together. And so what we want to try to do is first create a new repository. A repository.
Create repository online access.
You have to say like.
It says create repository. You should just press that.
Create repository?
Yeah,
Where's that?
that's on my end. It doesn't say new on my end.
Oh, okay. Then you can just.
Or a different page, maybe.
I'm on the browser.
Okay, you can just create a new repository. It'll probably do the same. Does it look like this?
Yeah, it does.
Okay. So a repository is just basically a project, and you can work with multiple people on it. And so we'll just create a repository called test. Or for me, I already have one called test, so I'll just call it test 2.
Just test it out, just
call it whatever you want, up to you. And there's a setting that says add a README file. You should select that. And then we can create our repository. Okay. So now that we have our repository, we have this README file that we just added, but we don't have anything else. And at the bottom, you can see that in the README file, it just has the title of your repository. And so let's go back to the slides. Downloaded. Create a new repository. Okay. So what we want to do now is create a branch. So a branch is basically just another version of your project. So you don't want to just have one project and then everybody updates that one same project, because it's possible that you have conflicting updates. So if you change this and some person changes that, it might not work out at the end. So it's better to split up what is happening. So we can create a new branch. Let me go in here, and I want to create a new branch called second branch. And then there should be a button here that says create branch from main.
Where'd you go for branch? I'm kind of lost with mine.
There's a button right here.
Main?
Main.
Okay, I get it. Branch?
Yeah, and then you can type in whatever you want to call it, whatever you want to name your branch. And then there should pop up like a button here that lets you create a branch with that name.
First branch. Let's see.
Okay.
And create branch?
Yeah, create branch.
Okay.
So now that instead of the main button, we have this thing. And so it shows that we have two branches here in our repository. So we can switch back to main, but it's the exact same thing because we haven't changed anything. Let's go to our second branch. And so we can go to the code button. It's a green button on the right. And so there's two things we could do here. So we could clone the repository and then use Visual Studio 2022 to modify our project, or we could go to code spaces. And code spaces is just coding, but on your browser. So if we open a code space here,
It's like Visual Studio Code.
yeah, exactly. Okay, so right now open is the README file. So we can create whatever file we want. We can just, if we create a new file, we can call it hello.py. We can do the basic, program, print hello world. And we can run this if we do Python hello.py. And it says hello world. Right there.
Where do you press for run?
Do what?
Where do you press for like to run it?
There should be a terminal at the bottom. And you can type in Python space hello.py.
I pretty much typed in all the code. I just need to run it now. Oh, I see now. Run a debug. Run a debug. Find Python extension? I don't have one.
Oh, yeah, you don't need to, go to running debug for this, or I guess you could. I haven't tried this. I'd rather not for now. You could go, to run the program, you could just go to your terminal at the bottom and just type in Python space hello.py, and it should print your print statement from your Python file.
And it did that.
Okay, perfect. And we could add whatever we want. We could just say random, we can create a new file, random.txt. Now we have a random text file. And we don't have to do anything with it.
How would it look like if we were to load, the code from the, C++? Like if we wanted to just like copy it and put it on there.
Yeah, because it uses SFML, and I think then, I'm not sure if we would be able to use the zip file stuff that we did to just easily just,
You could
open it up.
extract it and upload the whole thing now. All the
Yes, you
files.
could.
Because I've seen it before. Like the whole thing is uploaded, all the assets.
Yeah,
And you pull the whole thing. Because
Yeah.
legit, I pulled it from a GitHub.
oh, you got the SLN from a GitHub?
All the files, the other second one with all the folders,
Uh,
that's from a GitHub. My professor had it. I didn't even need Git to download it. You just go to the Git website, whatever, you just hit download, it gives you all the files.
Okay. Wait, did
To
you
merge with it, you need Git, but to pull the files, you just go to the website, to the link.
Interesting, okay. Okay. So, we're on our second branch, and we have these new files that we just made. So, we're gonna use git from the terminal. So we can say git status. And so it shows us untracked files. We have two untracked files, hello.py and random.txt that we just created. And so in order to get from the code, the files that we just added, we have to go through this process. So we want to add the code to the staging, and then commit that. And then after we commit it, then we can push it to the repository. And so basically, it says right here that we can use git add to track. So we could git add, and then we could put in the names of our files, hello.py, and seemingly it does nothing, but if we say git status again, now we have this right here ready, and this still untracked. And so we could do git add random.txt, or for a shortcut, you could add everything untracked, which is add period. So when we do git status again, now all of our files are ready. So here changes to be committed. So now we have to commit these changes. So we could just do this with git commit. But we want to add a message to it. It's just professional practice. So we could do that with -m. I think it's like that. Let's check. On the slides we have, yes, git commands. So git commit, we could use this to commit our staged changes with the message. So we go back here. We added 2 files. Then we have committed our 2 files. But now we want to push this to our repository. If we go to our repository and we're on the second branch, there's nothing that has been changed. We still have the readme file, and we don't have our hello, and we don't have random.txt. So we do git push. We've committed everything. So now we can push everything that we've committed to the repository. Now if we check back, we've had push. And now our files, after we've refreshed the page, are here in our second branch. So that's how you get your code from a code space, or we could do this in Visual Studio as well. And that's how you get to GitHub.
So you refresh the page on GitHub?
Yeah, after you push it with git push. And of course, you could always review the commands from the slides. They're very helpful.
Okay, I got it now.
So the thing is, we still have main and second branch being separate. So if we change the second, on GitHub, if we change our tab to the main branch, we still have nothing here. And so our goal is to to merge our second branch onto the main branch. So we could do that by compare and pull request. It's a button right here. Okay, so when we get here, it'll ask you for a title, description, say added low.py and random.txt. And we can create our pull request. Okay, so this will load for a minute, and then it'll give us an option to pull the merge request. So if we do that, we can just leave that as default, confirm the merge. Now it says pull request successfully merged and closed.
What do you press if, what do you do in merge requests?
Did you do the compare and pull?
Yeah, I did that.
Okay. And then once you do this, you should see something like this, and you can create a pull request.
I think I already created a pull request.
Okay. And then after you create the pull request, you can merge the pull request.
So like add it to files, we just leave it there.
Huh?
We don't write anything in it.
You could add descriptions if you want. Up to you.
Okay. Pull request successfully merged and closed. Okay.
Yes. Okay. So if we go back to our code tab on the top left, and we check our main, we're on the main branch, and now we have our files that we had from the second branch now on main. And so, if you want, you could go back to pull requests, the closed tab here, open this up, and you could delete your branch, because we're not using the second branch anymore. We just used it to merge to main, and now, let's just say I don't want it anymore. Delete the code space as well, just, so if I go here,
You like delete second branch?
yeah, you can delete.
Hold on. I don't know why it's not popping out. I can delete it. Oh, delete branch.
Okay, let me go slower. So you went to pull requests?
Yeah, I'm
And then
there with that.
closed, and then opened main, and then there should be options here.
I have that on. And now I delete branch.
Yeah, you can delete the branch and the code space.
Delete code space. Already done.
Okay.
Appreciate it.
Yeah. So now when we go back to our code and we check the tabs here for the branches, we only have the main tab. The second branch is in fact deleted. And so basically, that's pretty much it. So we went from the code and we staged it with git add, and then from there we did git commit, and then after that we did git push to push everything to our repository. And then after that, we went from our repository, addressed the pull request, and merged it to our main branch.
I'm gonna have. See you later.
Take care. Yeah, take care.
So it's on the slides if you want more
Yeah.
directions.
Yeah.
Thank you.
Okay. What's this? Well, we can just, Professor, do you want to show your genetic algorithm? Sure. Actually, I think I could do it. So in the slides, there's a link to Professor Marsh's, there's a GitHub repository of his. So if we open that, we have his repository. And so what we could do is we could clone the repository, which means to basically get this code and deal with it on our own local system. So what we could do is open this code button, go to the local tab, and there's a link here. And there's also options here, open with GitHub Desktop or Visual Studio. So I'm going to open it with Visual Studio, but I'm going to do it from Visual Studio. So I'm going to open Visual Studio here, and then it gives us an option, clone or repository. So when we click that, we could, there's a, a text area where you can post the link. Okay. Just go to this one desktop. I'm gonna create a new file or a new folder real quick. That works. Okay. So once we select a path to wherever we want to put it, we can clone it. Okay, so we can open up the folder. have is code here. Takes a minute. Okay. So these are all JavaScript files, and then we also have an index HTML file, which is for web pages. Okay, so we'll just open this in our file explorer. And so how we run the program is we can just simply click the HTML file from the file explorer. And we can see its program run. Pretty cool. Do you want to provide some commentary to tell them how it works?
Sure. For those of you who haven't seen it before, I've showed this up in past semesters. This is doing a genetic algorithm, so machine learning. So what it's going to do is it's going to try and teach the bubbles how to reach the bottom of the area, the play area. They move around, not at random, if you believe it. Each bubble has its own quote-unquote brain, which is just a set of directions to follow. And it runs them for 500 cycles each. Then it takes the ones that perform the best, which is the ones that got the lowest down on the screen, and uses those and basically throws out the bottom half, the worst half, and then takes the top half and creates a new generation by mixing and matching their brain pieces together. So, also a little bit of mutation thrown in there, so a little bit of random chance for them to move in different directions. So effectively, slowly it's going to, it's called a genetic algorithm because it's like the process of evolution. You have this population, some do well, some do poorly, they're color-coded based on how they're doing. And the ones that do well, quote-unquote, reproduce to create the next generation, which is just a little bit smarter. And so on and so forth. They get penalized for hitting the blockades, the gray blockades, and their goal is just to get to as low down as possible. So if you just leave it running for a while, they will slowly work their way down. Every so often you'll see one that's particularly smart make it further down than the rest, and then slowly but surely, the good brain genetics will pass on to the next generations on and on and on until they learn to do better and better. So already, at the very start, it's all kind of happened fast, but at the very start they were all very clustered around their starting point. But now they're learning, most of them are learning, to head down and to the right. You can't go down to the left because they need the blockade, so they learn to go down and to the right. But then they have to learn to swerve left, and that's what they're struggling with. You can see a couple of front runners are already over there, and they are likely passing on their genetics more, but otherwise it's going to take some time for them to learn. And so eventually, if you leave it running for long enough, they'll eventually learn to snake all the way around and down to the bottom, which is their goal. Yeah. It's just a program that I coded up a few years ago just to show off, to mess around with the genetic algorithm. I was interested and wanted to do it for myself. So just a simple few JavaScript files and an HTML page just to show it. Yeah.
Yeah, cool stuff.
When it gets to the middle, does it split evenly and go to each side, or will it go to one over the other?
No, they typically only go to one or the other because they learn really only to do one or the other, and it's usually left. Since they swerve right, then they swerve left. Usually they learn to keep going left before they go right again. But theoretically, it's possible for them to learn to go back over to the right. But they're all going to work as a mob because this is a very simple genetic algorithm, which only is really trying to perfect the one quote-unquote gene to reach the bottom. There's no subspecies allowed, as it were. Although genetic algorithms exist which do allow for that, so you could theoretically have like species A that goes left and species B that goes right. It's a fascinating topic. Unfortunately, been left behind by other more advanced machine learning algorithms that have come out since then. The field of AI is advancing rapidly. I find the genetic algorithms are the funnest to watch at the very least, because you get a whole population all trying to succeed at the same time. And it really does work like evolution. Like there's no magic in it other than what I said. Each bubble tries to do their best, and then we throw out the worst half and take the best half and mix and match their brains. And that's all it takes for them to slowly improve over time. Although they do get stuck for a while every time they reach block A. So they're going to be stuck there for a while. Then probably around generation 50 to 70, they'll very quickly learn to get down to about here. And then they'll be stuck there for another 50 to 70 generations while they learn to go around. But they're rewarded the further down they make it, and they get a huge reward when they touch the bottom. So the first one that actually reaches the bottom, it'll turn into a line of ants. They'll all just start making it because the reward is just that big. All in all, the actual code making this run, I mean, the concept of the genetic algorithm is obviously a bit complicated, but the actual code required to make this run is really not that complex. I wrote it in an object-oriented design, so it's, you know, if you haven't taken 400 or 401, that might look a little foreign to you, but the actual, like, brain part of this, the actual sorting and handling of the brains is nothing complex. You know, it's just score them based on how far down they get, which is just a pixel position. So just take those numbers, throw out the bottom half, you know, sort them, throw out the bottom half, then take the top half, and then just randomly pair them up until you have enough new bubbles to run the next generation. Oh. Nice.
Oh no, they're dead.
Oh, there you go. And so it's keeping track of, you know, we're on generation 44 now, so they're finally starting to learn to spill out over the side of that first barricade. The overall best score is 348. The whole area is 500 tall, so 348 is decent. But that's the overall best, so that's the best that we've seen so far. That doesn't mean the average. And then it shows us since the last generation how did they improve, which sometimes it'll go down, but it generally trends upward.
362.
Yep. There is, if you look really closely, there is one cyan bubble, and that is the current frontrunner, the one that has the highest score. It jumps around as different ones. See, that this guy, right at the very end, the guy that made it really far down, 70 best, he made it blue. But whichever one is currently holding the highest score is colored blue. See, some of them are learning very fast, but like a real world population, it doesn't matter if one of them has incredible genes. It can only have so many children on its own. So the mob is slowly learning, but you know, we've, like I said, around generation 50 or so, they're learning to spill out over the side of that first barricade. And then they'll get stuck on the second one, or the third one. So yeah. Any other questions about it? One of these days I might need to make like a screensaver version, but it's just fun to watch. It was all designed just, I came up with it all on the fly, like the way the bubbles look, I just kind of made it up as I was going along. But the color gradient was meant for testing, but it just looks nice.
So this is like, I guess, the power of GitHub. We can get kind of code from anywhere, be it a professor or you know, any online source, SFML from GitHub as well. And you don't necessarily have to understand exactly what's happening. I mean, if we open up the code, it's like if you haven't seen HTML, then this is not going to make sense to you. But at the same time, you know, we can get the code to run, which is pretty cool.
Yeah, it's basically, Git and GitHub have changed a little bit over the years as they've been developed. I mean, it used to be, you know, very much a professional tool. And I mean, it is still a professional tool, but now it's kind of changed into almost programming social media. In that you can just share your code and see what other people's code is and collaborate with people on it. Like there's, you can make your own versions. That's what the whole branching is. You branch or fork. You fork someone else's project, and have your own version of it, and if you like it enough to add on to it and make some new features, you suggest that it gets added to the real version, and the person who owns it might say, yeah, sure, you did a good job. It's a good open source tool. Yeah, I mean, my project here isn't like famous at all, so it'll be hard to find just by virtue of my name being invisible. But more popular projects, you can just look on GitHub and download the code. If it's on GitHub, you can have the code. You can download it and use it for yourself.
Wait, Alex, when you did when you downloaded the GitHub for SFML, you also have to, that's when you also have to download from
Just
site.
now, if you go back, when you ran the thing, there was a download zip option
From GitHub?
for this program here.
Yeah.
When you did it, there was a download zip. You just download all the file.
Yeah, when you, to get from GitHub, if you want to follow the GitHub procedures, you can do the pull and all that, but you also can just download the zip.
Yeah, so what you're doing right now, instead of doing the link, you just download all the files. And you uploaded a text file and a JSON file. My SFML was different. You're just uploading the files and then just pulling them back down. Right? Because look at this one. If you go back and look at what this page entails, when you go to his link, Gideon's link,
Yeah.
when you hit code, see it's just files, right? HTML, .j, whatever.
Yeah.
You could upload all those on your GitHub. And when you hit code, the green button there, the bottom one says download zip. And it'll just download this whole folder.
Okay.
So if you extract my SFML preset folder, upload all those files to your Git, people could just download zip that entire folder.
Gotcha. And they don't need to download from the site,
Whose site?
the library.
The preset that I made already has SFML in it. Everything is put into the same folder.
Oh, okay.
Like, the problem is, if you want to run other SFML projects, you just have to copy and paste them into that project. Because what technically if you're running SFML, you want to just throw it into your C drive, and every time you make a new project, you just point it to that folder. The preset that we have on the Discord points to itself.
Instead of, like, normally you would, download the libraries onto your computer so you have them everywhere.
Yeah.
That preset SFML has all the stuff it needs within itself. So it's a self-contained thing. But if you wanted to make a second
Yeah,
project.
if you go to the SFML website, they're gonna go, here's the files, put it into C drive,
Yeah,
and when you make a new project, go ahead and point it to here. I'm saying, here's all the files, they're all in the same folder.
And
Gotcha.
the advantage is that you don't have to muddle around with the Visual Studio settings of actually.
Yeah, there's like a chunk of properties you have to set up.
Change the linker location, change the, I forget what they all are.
There's like a lib, there's a linker, and there's one more.
Yeah, like.
I think those main two.
Assembly path, something like that. So it's just a bit of a headache.
Okay.
It's not like we can't do it, and if you were working on this
Yeah.
for a real project, you would go through all the steps.
Trying to get 10 different people to set it up, there's gonna be like half of them are gonna have issues that you're gonna have to go through and figure out. But since it's all set up into one folder, you don't have to do any of that.
It's a great
You just go ahead, like, yeah, it's all there. It's sort of like, let's say you have a picture in your documents and you're running a project. You go, okay, well, the picture's in documents, right? You have to type that out. Or you can move the picture to your project folder. Right? Then when you move the project, the picture moves with it. They don't go, hey, where's the picture? Oh, it's on my desktop. They're like, no, you needed to give it to me with the project. When you make a new project, it says use same directory or whatever. You could also sort of like that idea.
Okay. Gotcha. But, yeah, I mean, well, that was the presentation on Git and GitHub. I hope you learned something. There's definitely more features.
We did it.
But, yeah, I hope you guys can explore and take yourselves further with them. Yeah, thank you.
Like Alex mentioned earlier, there's going to be a separate Discord channel for the SFML. That way we can continue going forward with it. With the GitHub, the slides are there, and when I send out the feedback form today, you can let us know if you want us to continue diving deeper into the GitHub, or if you want us to continue fleshing out the game during the meeting time. So it's gonna be completely up to you guys, or if there's something that you guys are interested in. But for March, we are gonna be touching on some web dev, that's gonna be a part of it. But just let us know, give us feedback on what you guys are also interested in the forums. That way we can plan around it and create the slides and the presentations necessary to touch on the things that you guys are interested in. Yeah, feel free to hang out. You guys are more than welcome to leave. I believe we got 20 minutes left, so.
Very cool. So no survey? Is there a survey on Discord now?
Yeah, I'm gonna post it.
Oh, I could use scale to rotate the butterfly instead of the set rotation thing, now that I think about it. It would definitely made it turn before the grades.
Yeah, I looked it up, to make something rotate around its center, you just have to change its center.
No, remember, so when I first loaded the Butterfree, it was facing the wrong way.
Right.
And I did scale -1,
Right.
1,
Oh, yeah.
and it made it face the other way.
Yeah, you can do that too, that you just, flip and rotate the needle, but you can also, if you wanna do.
Rotate on the spot?
Rotations around the center, it's, I think it's like, set origin point.
Yeah. You could make it set to the, because like, again, I talked about it the last couple of times. It draws from 0, 0 of the image, but you can make it set to the minute.
Yeah.
You could get it, what was it? You could load in its sizes, get, there's a get size or whatever it is, and then set origin to size by half, height by half, or whatever it was. And then it'll rotate. I wonder if the rotate is, changing origin or rotating is more efficient than changing scale?
It depends. I mean, if you're just going to be popping to the different, then I imagine the scale's better because it's an instantaneous action. Whereas a rotate is every frame. Well,
But it's set
yeah,
rotation, it's
yeah,
not moved
yeah,
by
if you're-
one.
Yeah, if you're just doing it and popping, I guess, if there is a difference,
Scale.
if
I
there-
wonder,
if there is a difference, it's because equal territory.
because both are using the sprite objects, right? So it doesn't even matter. They're not actually messing with the actual texture, I guess. It's messing with the texture already loaded in.
My gut feeling is that the scaling is probably slightly faster, but that's just, I don't really have any proof of that, that's just a gut
Yeah,
feeling.
scale sounds like it's just loading in the image differently,
Yeah,
right? Because the negative one means it's scaling from the other side. If it's loading in this way, but when we make it negative, it's loading in this way. Loading in. Who knows? But either way, that's an easy way to rotate. If the thing keeps going, chapter 6, 7 is the pawn game that does collision detection,
right.
right? So, that's only a couple chapters. We'll see once you get through them. So the survey is not like a multiple choice, it's a fill in the blank. I assume, I was on the, that's how we're gonna pick. So guys, welcome back. We made it.
How you doing? I'm in.
We're get ready. Are you get it ready?
I get it.
Did you get it?
Oh, man. Yo, hey, Christian. So something's wrong with the, permissions on the GitHub. Not all the channels, you can't see all the channels. Like Ryan, he's just a normal member, he doesn't even have access to the general discussion. So that means everything that's being posted in general, no one can see. He doesn't have the permission to do it. So I'd look to see if there's some problem there. Because that might be hurting.
They can see announcements though, yeah.
Well, yeah, you can see the announcements, you can see like the other two ones that like hardly anything is posted in
Interesting.
I don't think we've had anyone join that meeting on the Discord.
They don't have the text channels. They just have information, club events, and
You could open
website and share.
a private window in
But
the browser.
they don't even need any of those, they mostly need the text channels.
Copy the channel link, open a private window in like your browser. That way you're not logged in. So you can just go to Discord not logged in and see if it shows all the channels.
Yeah.
If you wanted to check it.
I mean, I don't have admin on Discord.
No, I'm saying if you could go into Discord without being logged in to see if the channels are showing or not.
Yeah, check.
But maybe it's just like this one outlier and everyone's working fine.
I don't know, it seemed kind of quiet in this.
True.
So, yeah, I don't know. Might have just been a thing, but I just noticed it when I was on the laptop.
Yeah, I don't think we have admin. I think only, we're in Juan.
Asking the past admins. You
Yeah, I was looking maybe is there might be a login in the Google Drive. Or yeah.
Oh, like the general, science is
I don't know what courses to take, what classes to take.
301s, probably, if you can show up to class, crop shot.
Yeah, I've been taking
The first class is 301.
So,
301 is the first computer science class. Then it just goes from there. You need 301 for like all of those. If you want to take 360, 310, you need 301.
Did we ever
CIS
figure out a way
P.
to get the preset SFML to run on Mac?
301.
Not for.
I don't know, yeah.
Does Mac use the
You need P.
P?
P. C means core. Means
I
like
had some of
basic
them.
computer stuff.
I had some of
But programming is all CIS.
stuff on their website, I was seeing from there. Honestly, I've been doing other things.